All right, so in this video, we're going to go over central angles and arcs. As with any new topic that we learn, we always get the definitions out the way first, right? So we're going to have some definitions and we'll put some meaning to these definitions using pictures. So first topic, an angle whose vertex is the center of a circle. So here we have, call it center C. And if we create an angle inside the circle and the vertex is at the center, we call this the central angle. Central angle. So if this is, let's just, I don't know, make up some numbers, 75 degrees, well, then the central angle would be 75 degrees. Not only that, but you could look at it as, so if we call this A and B, this would be angle ACB. Remember, when you have three letters, we always look at that middle letter as the vertex. Right? The middle letter is the vertex that we're talking about. And again, we said this is equal to 75 degrees because we just made that number up, right? It could actually be anything. Okay. Part 2. If the endpoints of an arc are the endpoints of a diameter, okay, so let's show what this is talking about. So remember, a diameter is the longest chord that goes through the center. Call it D and E. Okay, if the endpoints of an arc, so let's say we have an arc. I'll use red or blue rather. So here we have the diameter DE, and we have this arc. So an arc is a length on the circumference of a circle. If the endpoints of the arc are endpoints of a diameter, then we say that the arc is a semicircle. So semicircle, semicircle, semicircle. If the endpoints of the arc are the endpoints of the diameter, right? As long as they match up, the endpoints of the arc are also the endpoints of the diameter, well, then this is a semicircle. Okay, a couple more arcs that we can talk about. If the measure of an arc is less than 180 degrees, right? So this is half of a semicircle. So if it's less than half, well, then we call it a minor arc. Actually, let's back up for just a second. Going back to the major arc, or I'm sorry, not the major arc, but the semicircle. The semicircle, we could call this, so here, look, A, B, C, D, E, F. So if we had another point here, we could call this semicircle. So the way we would say this is D, F, E. So you would take points that are on the arc, and then you would put the arc over the top to signify that you're talking about the arc. So DFE, that's one way of describing the semicircle. Another one would be arc DAE or arc DBE. Now, obviously, you could reverse the letters, right? EBD, EAD, EFD. You could write them in reverse as well, but this is how we would say the semicircle. We would use three letters. All right. Now, remember the diameter would be 180. So this measures 180 degrees. So just know that 180 degrees is a semicircle. Okay. Now, if the arc is less than 180 degrees, well, then we say that this is a minor arc. It's a minor arc. Right, less than 180 degrees. Minor arc. And minor arcs are named with two letters. So we can do this one in green. So DA is a minor arc. AB is a minor arc. BE is a minor arc. So see if you can see it on the screen. So yeah, you can. All right, so arc DA, arc AB, arc BE. These are just a few examples. And then you could write them backwards as well. AD, BA, EB. Just as long as it's less than 180 and you use two letters. So you can actually do like DF, FD, FE, EF. All right, so anything less than 180. I guess I could have used this picture right here also as well. It really doesn't matter. Just as long as you understand that 180 degrees is a semicircle and minor arc less than 180, two letters. Here, if the measure of an arc is more than 180, well, then this would be a major arc. It is a major arc. And we use three letters. So two letters, minor arc, less than 180. Major arc, three letters, more than 180. So for instance, more than 180 degrees. All right, so we have to go the long way, right? More than a semicircle. So we would call this arc RSU, arc RTU are some examples. Now, notice it has to go more than 180. That's the big one. Now, it could be 180 as well, but 180 is a semicircle. More than 180 is a major arc. Is a semicircle a major arc? That's the question. I don't know. It depends on who you ask, right? But just as long as you understand the difference between minor, major, and semi. Okay, and an arc addition postulate. Okay, so if you think back to when we are dealing with segments, right? And you add two segments together, you get the whole segment. Well, this is the same idea, right? If you take two arcs and you add them together, then you get the measure of both arcs put together. So watch. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Is the sum of the measure of the two arcs. So here we have arc RS plus arc ST. Now, if we make up some numbers, I don't know, let's see. Making this up, this would be, choose red. So 80 degrees, call this 15 degrees. So then, so what we're saying is arc RS, or the measure of arc RS, plus the measure of arc ST equals 80 degrees plus 15 degrees equals 95 degrees. So if you have two arcs that are next to each other, you add them up, you get the whole amount. Right, too easy. Okay, the last one. Yeah, I guess I could have used that in the circle up here. Okay, so I'll just draw it in. So you're gonna have to draw this one in. Okay, so in the same circle or in congruent circles, two arcs are congruent if and only if their central angles are congruent. Their central angles are congruent. So what I'm saying is, so you have two circles. Or the same circle, rather. Again, we can call this center C. What this is saying is, if the central angles are congruent, the arcs are also congruent. That's what this is saying. So if you have a circle and the central angles are congruent, well, then the corresponding arcs are also congruent. All right, let's see some examples of the definitions, right? All right, first example. The measure of AXB. Well, it goes through the diameter, right? AB, the segment AB goes through the diameter, and our definition says that an arc whose endpoints go through the diameter, also on the ends of the diameter, then it's a semicircle. So 180 degrees. Okay, number 2. So the measure of CY. So CY is here. The arc matches the central angle, so 120. It's kind of nice when the arc matches the central angle. EZF. Okay, this is referring to the arc. So EZF, so this way. All right, so we have to know that the only information they gave us was that this little one right here is 60. Okay, well, there's 360 degrees in a circle. So EZF is 300. Right, because 360 make a whole circle. So it would be 300 degrees. 300 degrees. All right, IJG. Again, this is arc IJG. So let's see. IJG. So this is why major arcs have 3 letters, right? Because it kind of tells you the direction of which way to go. I to J to G. This one we're gonna have to add some things together because we know that this side right here is a semicircle, half of a circle, and this little piece right here is 70. So 180 plus 70. 8 and 7 is 15. So this is 250 degrees. 250. Okay, measure of HI. Again, this is the arc HI. We'll do it in blue. So HI is going to be this section right here. Okay, it's going to be equal to this central angle, so we have to figure this guy out. The only thing we got to go off of is that this is 70 and this is 70, and everything needs to equal 180. So, well, the semicircle is 180. So I'm going to take away 70 twice, basically. So 180. So 70 and 70 is 140. So if I take away 140, we get 40. So this right here is 40 degrees. And if you add them all up, 70, 70, 40, you get 180. So HI is 40 degrees. All right, and the last one, the measure of arc GI. GI. So we're saying from G to I. From G to I. It's the minor arc. Now, again, this is why minor arcs have 2 letters, because if I just say G and I, technically I could go this way to G to I, but because we know that 2 letters is a minor arc less than 180, so it's the shorter distance. So this is going to be 70 plus 40. 110. So 110 degrees. Okay. All right, next topic. Let's talk arcs and chords. Just remember what a chord is. It's a segment that has its endpoints on the circumference of a circle. So we are going to look at some examples of that. All right. So in the same circle or in 2 congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. Their corresponding chords are congruent. So what this is saying is, say I have again, I'm just making this up, right? We have some chord. This is the definition of a chord. And say you have a second chord. So here we have chord AB and chord CD. All right, what this is saying is that if I tell you that the chords are congruent, right? We use a tick mark to signify a chord. Well, then this means that their arcs are going to be congruent as well. So if we have another one, so you could have multiple. E, F. So here we're saying that segment AB is congruent to what I say CD, and that's congruent to segment EF. Well, if this is true, right? These are all congruent if and only if. This is the shorthand for if and only if. If and only if arc AB is congruent to arc CD is congruent to arc D, I'm sorry, EF. I feel like color coding is better. All right, so AB, CD, EF. So as long as the chords are congruent, then the arcs will be congruent. That's the big takeaway there. All right. If a diameter of a circle is perpendicular to a chord, so remember, perpendicular means 90 degrees, right? Intersects at a 90 degree, at a right angle, perpendicular. Then the diameter bisects the chord and its arc. So what I'm saying is, here we have a circle. Here's a random diameter. So again, we can call this AB. AB is the diameter of circle C. And suppose that that diameter intersects a chord DE. Well, then it's perpendicular. That's what this is telling us. So if the diameter of a circle is perpendicular to a chord, which it is 90 degrees, then it bisects the chord. So that means it cuts it into two equal pieces. Not only that, but it bisects the arc as well, right? It cuts the arc in half. So what this is saying is, if AB is perpendicular to DE, then here we can call A, B, C, D, run out of letters, A, B, C, D, E, F. So that intersection point is F. Then DF is congruent to FE. And arc DB is congruent to arc BE. Right. As long as that diameter is perpendicular to the chord, it'll bisect the chord and it'll bisect the arc. It's kind of nice. All right. If chord AB is a perpendicular bisector of another chord. Okay, so let's see what this is talking about. So we have chord AB, random chord A, B, and it is perpendicular to another chord. So let's call it C, D. So here we have two chords that are perpendicular. Oh, wait, it says perpendicular bisector. Okay, that's not going to work. Not going to work. Then it has to be the diameter. It has to be the diameter. So all right. You have a chord AB and it bisects. It is a perpendicular bisector. So that means that the other one is okay. So CD is going to be the diameter. I feel like so AB is a perpendicular bisector. So AB is supposed to cut it in half and equal. And I feel like this is backwards. Right, because we're saying that AB, if chord AB is a perpendicular bisector of another chord, so AB is the thing that is cutting in half and is perpendicular. Right, because for instance, in the last example, which one's the perpendicular bisector? Which line is cutting which in half? Is AB cutting DE in half? Yes, it is. Is DE cutting AB in half? No, it's not. So the diameter is the one that bisects the chord. So if AB is a perpendicular bisector of another chord, AB is the diameter. So what this is saying, sorry, I'm learning on the fly here. I misread that. So AB, if AB is the perpendicular bisector, then AB is the diameter. My bad for the confusion on that one. It's sometimes it's the way that the words are written. If chord AB is a perpendicular bisector of another chord, AB is the diameter. It's got to be the diameter. It's the one that's doing the cutting in half. All right. Last page, then we have some examples. All right. In the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So if they are equidistant, this is how it sounds. Equidistant from the center. So what this is saying is, let's say you have two chords We want to mix up the letters. Let's just keep it simple. A, B, C, D. So we have two chords. Okay, the two chords are congruent, right? These are the same length, A, B, C, D. If and only if they are equidistant from the center. So here we have to know that these chords are the same length from the center. Now, it is worth noting that these need to be perpendicular. Kind of wish the definition said that, but it has to be perpendicular. If it's not perpendicular, then we don't know that they're equidistant. So it has to be a right angle, basically. Okay, so if that's the case, well then AB, right? AB is congruent to CD if they're equidistant. All right. So that's the last little topic. So now let's see some examples and then we'll be done. All right, find the indicated measure of P. Okay, what's this saying? I feel like this is supposed to be a circle. Circle P. I don't know why it's not. Okay. We're using the circle P to answer the questions. All right, so CD. What is CD? Is CD, they're referring to the segment. Okay. So the diameter of the line going through the center is perpendicular to the chord AC. So that means DC is also 4 because AD is 4. 4 units, whatever that may be. All right, DF. DF is this chord here. And this kind of looks like the picture that we drew earlier. The only number they give us is 20, so AC is 20. They're equidistant from the center. Therefore, FD, or DF in this case, is also 20. So as long as you know what's equal, what conditions make the specific features equal, that's what you got to kind of focus on here. EP. EP. So EP is the little line. This is telling us, so look, so context clues, right? These are equal, these are equal. That means FD, AC are also equal. They meet at right angles. So EP is 15 because they tell us that, I guess, BP is 15. So EP would be 15 as well, since all the things match, right? Everything lines up, everything's equal. Some nice symmetry happening. All right, last example, and then we'll call it a day. BD. Where's BD? BD happens to go through P, which is the center. So that means BD is the diameter. Okay, what information did they give us? They gave us 2.3, and 2.3 is actually the radius. And we know that a diameter is 2 times the radius. So 2 radii added together. So this is 4.6. Okay, I know that this was pretty basic, but go back and see if you can review all the definitions and convince yourself of the measurements that we were looking at here. All right, good luck. See you guys in the next video.